Hello everyone, this is Dr. Lennon, and we're going to be taking a look at the final exam review. It's comprehensive, covers all the topics we've looked at so far this semester. So the first one basically is going to be a Pythagorean Theorem problem. So find the length of the missing side. And we have a right triangle here where we know the length of the hypotenuse, which is 10 meters, and the other leg, which is 8 meters. So remember, the Pythagorean theorem says in a right triangle, the sum of the two squares of the two legs is equal to the sum of the square of the hypotenuse. So if we call the missing side x here, we know that x squared plus 8 squared has to equal 10 squared. So we know x squared plus 64 equals 100. And then we go ahead and solve that remaining quadratic equation. So just subtract 64. And again, since this is a geometry problem, we don't have to worry about negative solutions. Everything that comes out is going to be positive only since it's representing a length. So we get x squared equals 36. And then you want to take the square root, so x is going to be the positive square root of 36, which is equal to 6. So 6 meters would be your answer here. Okay, so moving on, the next topic is just solving some linear equations. So the strategy, remember, is expand everything, combine like terms. Pick one side to move your x's to and the other side for your regular numbers. So we want to solve, and let's say we have, let's say 7 times the quantity 2x minus 3 equals negative 4 times x plus 9. Okay, so the first thing to do is to expand the 7 and the negative 4. Remember, when you multiply the negative 4 through, the negative stays with it. So on the left we have 14x minus 21, and on the right we'll have minus 4x minus 36. And I'm going to move my x's to the left and my regular numbers to the right. So that means basically I'm going to be adding 4x. So my x's move to the left side of the equation, and I want the minus 21 to go to the other side. So I'm going to add 21 to both sides as well. So I end up with 18x is equal to minus 15. And then I want to divide by 18 to get x by itself. So I divide both sides by 18 and then simplify that fraction. So I divide by 18. And the fraction's actually not quite simplified. You can divide 3 into both of them. So we end up with minus 5 over 6 as our answer for number 2. All right. Moving onward, let's go ahead and try one more of these. So number 3, let's say we solve, let's say 12x minus 5 times, let's say x plus 1, and let's say this equals 7x minus 3. So what we have here is, again, we need to expand. So we have 12x, multiply through the negative 5x, so we have minus 5x minus 5, and that'll equal 7x minus 3. So then your 12x minus 5x simplifies to 7x minus 5. So you have 7x minus 5 on the left, but 7x minus 3 on the right. Well, that could never be the same number, right? You could go ahead and subtract 7x, and you'd end up with something that doesn't make any sense. Minus 5 equals minus 3. So basically, the solution set is empty in this case. So that equation has no solutions. It's known as an inconsistent equation. So you could write that as well, but typically they would just say the solution set is the empty set, and you would stop there. So remember, when you have a linear equation, kind of three things can happen. Usually it just equals a number, but sometimes you get an empty solution set, and sometimes you get all real numbers. So let's go ahead and maybe look at another linear equation. So let's say complete the table for 5x plus 4y equals, let's say, I don't know, 24, something like that. So I have to give you a table. So let's say we have x and we have y, and you know some values of one, and you want to know the values of the other. So let's say maybe 0 for x, maybe 1 for y, maybe 4 for x, something like that. No, that would give the same thing. So let's change that. Let's make it I don't know, 3 instead. So basically we just plug in the known number and try to figure out the missing one. So the first thing, if we plugged in 0 for x, we'd get 5 times 0 plus 4 times y equals 24. 5 times 0 just becomes 0, so that vanishes. So we're just left with 4y equals 24. And we can divide by 4, and we end up with y equals 6. So this would be our first answer. Then we'd want to plug in the other one. So let's plug in 1 for y now. So we'd have 5x plus 4 times 1 equals 24. So this would be 5x plus 4 equals 24. We want to subtract our 4 on both sides. So we have 5x equals 20. We divide by 5, and we have x equals 4 as our answer here. So 4 would go in this missing cell. And then the last one we would want to complete with x being 3. So let's do that again. We're going to replace x with 3 now and solve for y. So we would end up with 15 plus 4y equals 24. Then we need to subtract 15. So we have 4y is equal to 9. And then we divide by 4. And that's our answer, 9 over 4. So y is 9 over 4 in this case. So 9 over 4. And that's it. Okay, let's move on to number 5. So we start to get into rules of exponents. So 5, basically we just want to simplify. So let's say we have the expression 8x to the 4th, y to the 3rd squared. So remember, let's rehash our exponent rules over here. So the ones that are going to be important. The first one I don't think we're going to use in this problem, but if you have a to the m times a to the n, it's a to the m plus n. Second one, if you have a to the m raised to the n, in this case you multiply the exponents, so this is a to the m times n. And the third one is if you have multiple factors all being raised to a power, that power gets applied to each factor. So if you had, say, an a and a b raised to the nth, then this would be a to the n times b to the n. So we're going to be using rules number 2 and 3 to simplify this expression. First off, we have 3 factors inside, 8, x to the 4th, and y to the 3rd, and they're all squared. So we start by using rule number 3 and squaring all of those. So we have 8 squared, x to the 4th squared, and y to the 3rd squared. 8 squared we know is just 64, and then for the remaining two factors, we're going to apply exponent rule number 2. We need to multiply those exponents. So we multiply 4 and 2, and we get x to the 8th. Then we multiply 3 and 2, and we get y to the 6th. So we have 64, x to the 8th, y to the 6th. And that is the simplified expression. Let's go ahead and try another one where we're going to make use of those rules. So 6, let's say we simplify. Let's say this one we have x to the 5th to the 3rd times x squared to the 7th. Okay, so this one is going to make use of rules number 2 and then we'll use rule number 1 after that. So the first thing is multiply the expression, or multiply the exponents of each of the two factors. So 5 times 3 makes it x to the 15th. And the second one, 2 times 7, is x to the 14th. Now, they both have a base of x, so we can apply rule number 1. So we're going to add those two exponents. So this will be x to the 15 plus 14, or x to the 29th. And that is how you simplify number 5. Okay, after that we talked about systems of equations. So let's go ahead and do a couple systems of equations. We learned two main methods, the substitution method and also the elimination method. So let's do the first one by substitution and the second one by elimination. So solve by substitution. Of course, you can just use one method if you really prefer it, but it's nice to know how to be able to do both. So let's say we have, I don't know, 2x plus y equals 4, and 3x plus 4y equals 15. So what I'm going to do first is I'm going to solve for y in the top equation. So I can just subtract 2x, so basically I get y is equal to minus 2x plus 4. So now in the second equation I can replace the y with minus 2x plus 4 in parentheses. So I can write down 3x plus 4 times minus 2x plus 4, replacing the y, equals 15. Now I'm just left with a linear equation to solve. So I'm going to multiply the 4 through. So I get 3x minus 8x plus 16 equals 15. So I have minus 5x plus 16 equals 15. And then I go ahead and subtract 16. So I get negative 5x equals negative 1. So I divide by minus 5, and I get x is equal to 1/5. So that's one of my two. Remember, I need to find both coordinates. For a system of equations, you need to find x and y. So to find y, I'm going to come over here. So y is negative 2 times this 1/5 plus 4. So y is negative 2/5 plus 4. And let's think of 4 in terms of fifths. 4 would be the same thing as 20 divided by 5. And that gives us our answer. So y is going to be 18 over 5. So x was 1/5 and y was 18 over 5. Most likely, yours probably won't have fractions, but I just kind of made up the numbers. So it's less likely you're going to get a nice answer when you just kind of pick them at random. Okay, so for 8, we'll do it the other method. We'll solve by the elimination method. So solve by the elimination method. So what do we have here? Let's say we have 3x minus 4y equals minus 6, and minus 4x plus 8y equals 8. So basically what you want is you want to pick a letter, and then you want to multiply one of the equations or both of the equations so that they have the same coefficient, the number in front, but opposite signs. That way when you add them together, they'll disappear. So an easy choice here is going to be y. If I multiply the top equation by 2, I'll have a minus 8y, and when I add that to the bottom equation, it will cancel with a plus 8y. So basically the top equation, I'm going to multiply everything by 2, and the bottom equation, I'm going to keep the same. So the top equation will become 6x minus 8y equals minus 12, and the bottom equation will be minus 4x plus 8y equals 8. So we add together, just add vertically, and we end up with 2x. The minus 8y and the plus 8y go away, and minus 12 plus 8 is minus 4. So we can divide by 2, and we get x equals minus 2. Again, that's just the x coordinate of the ordered pair. We're going to need to plug into one of the original equations to solve for y. So I'm just going to use the top original equation to solve for y. So I'm going to say, okay, I've got 3 times negative 2, replacing x with negative 2, minus 4y equals minus 6. And then I want to solve this, so I get negative 6 minus 4y equals minus 6. So I add 6 to both sides. So I end up with minus 4y equals 0, which means you could divide by negative 4, but that means y is equal to 0. So that's our y coordinate. And you can check that that's true by plugging both of those numbers into both equations. You see if you replace x by 0, or x by negative 2 and y by 0, 3 times negative 2 is negative 6. And if you do negative 4 times negative 2 and put 0 in for y, you get 8 for the second equation as well. So that's the answer to number 8. Okay, so the last topic we looked at was quadratic equations. So let's go ahead and do a couple. So we'll do one using the square root property, and then another one via the quadratic formula. So solve by the square root property. So remember, the square root property says the solutions to, so square root property, I'll just recall it. So let me write down the equation, then we'll review the square root property. So let's say we have, I don't know, 7x squared minus 8 equals 41. Or let's not say 41, let's say, sorry. I don't know. Let's just say 6. But the square root property, that's all it says is the solutions to something, any algebraic expression, something like a squared equals k, are a is equal to plus or minus the square root of k. So what we want to do is just isolate that x squared and then apply the square root property. So that's what we aim to do here. So we have our 7x squared minus 8 equals 6. So we start by adding 8 to both sides. So we have 7x squared is equal to 14. Divide both sides by 7. So we have x squared equals 2. So our solutions are x is equal to plus or minus the square root of 2. And those are your answers. Number 10, we're going to use the quadratic formula, so it's going to be a bit more there's a bit more arithmetic to it, let's say. So we'll say solve by the quadratic formula. So let's say we have something like, I don't know, 5x squared excuse me, minus 11x plus 2 is equal to 3x let's say plus 1. Okay, so let's recall the quadratic formula. Again, you don't have to memorize it, but if you end up using it a lot, it's good to have committed to memory. So the quadratic formula says the solutions to ax squared plus bx plus c equals 0 are x equals negative b plus or minus the square root of b squared minus 4ac, with everything being divided by 2 times a. So we have a little bit of work to do before we can get to the quadratic formula, because notice we don't have 0 on one side of our equation. We have the 3x plus 1 over there. So the first thing we have to do is move that to the left, and then we can apply the quadratic formula. So if we have 5x squared minus 11x plus 2 equals 3x plus 1, we want to start by subtracting 3x and also subtracting 1. And then we'll be ready to apply the quadratic equation once we simplify this. So we have 5x squared minus 14x plus 1 equals 0. So let's identify what a, b, and c are. So a is equal to 5, b is equal to minus 14, and c is equal to 1. So we can plug these things into the quadratic formula. So try and keep it on the screen for you. So we have x is equal to, well, if b is negative 14, that means minus b is positive 14. And that's going to be plus or minus the square root of b squared, so negative 14. Remember, that needs to go into parentheses so that when you square it, it actually becomes a positive. And then we have minus 4 times 1, well, times 5 times 1. A is 5 and c is 1. And all of this is being divided by 2 times 5. So let's try to simplify. So we have x is equal to 14 plus or minus the square root of 196 minus 20 over 10. And this would come out to x equals 14 plus or minus the square root of 186 divided by 10. We could simplify this a bit more maybe. Again, from roots and radicals, we'd have to see exactly what the prime factorization of 186 is. So we could try that to see if there's any squares we could cancel out. So let's see. I know it's divisible by 3 for sure, and also 2. So that means it's divisible by 6. So if you put 6 into it, you would get 31. 31 is a prime. So this is 2 times 3. So basically, this is, you cannot simplify the radical. So this answer is basically as simplified as you can get. So we would stop right here. But it's good to check and see if there's any perfect squares inside. So that's it. Again, the exam can't cover absolutely everything we did, but it covers a fair amount of the topics. So this is Dr. Lennon signing off.